Good morning, and as always,
Slow is smooth, and smooth is fast.
so what we're going to be talking about today is units and dimensions. So we can use these units in our everyday life. So units are used in our everyday life without us even realizing it. When we talk about miles to the grocery store, when we talk about blocks to the grocery store, when we talk, I don't know why, I'm apparently hungry. When we use any kind of thing, we give it a unit.
Think about your day. You talk about it in terms of hours. You might talk about how many days of school you have left. Probably too soon to start that countdown, but you have those things. Those are units. And we use those units to organize and maintain apps. So let's start with a question. How do you know that if I give you $1 and a quarter, you actually have $1.25?
A base unit is one. So we treat it as a base unit is 1 cent.
Then what we have is $1 is 100 cents, and a quarter is 25 cents.
So all in all, we have 125 cents, which we can actually break down into a lot of different things.
We could even treat this though as a dollar, where $1 is $1 and a quarter is $0.25, and so together they make $1.25.
So I realize that there's a lot going on with us talking and writing. So keep in mind, you can pause the video, you can rewind the video. We have $1.25, just like we have 125 cents, just like we have $1 and a quarter.
And really, those are all the same thing. They all equal each other, but they're used in different ways as far as the units. And what's important is you notice we never added $1 to 25 cents. We actually converted the dollar to 100 cents and added it to 25 cents, or we converted the quarter to $0.25.
When we talk about physics, remember we're going to break it down into those 3 different purposes of physics, that mathematical, that visual, and
the narrative. Telling that story.
So, but to start that story, to start the math, to start the pictures, we need 3 different base units, and we're going to have time, length, and mass.
Now those are all terms, and so what we're going to do here is we're going to really understand what these terms mean, and then we're going to kind of help you see how we take those terms and we make them mathematically accessible for us.
So the base unit of time is a second, right?
Is a second. Now this is important. You can measure time in hours, minutes, days, months, years, decades, centuries, all sorts of things. What we're saying is in physics, our base unit is a second.
And so to keep it consistent, when we talk about the base unit for length, we talk about a meter, right?
Exactly. We talk about that 1 meter long object.
And then finally, our mass is going to be a kilogram.
Yeah, and so this is one area where the world of science is kind of divided. In the world of chemistry, chemists use grams as their base unit for mass, but physicists use kilograms.
So really, because physics deals with the real world, it deals with things about our size, or at least originally dealing with things about our size, we use the unit that's close to our size.
Exactly. And we just want to emphasize, you'll notice as we talked about kilograms, there's that asterisk there, and Mr. Schmidt kind of added something to this back wall. Anytime you see that asterisk, we're going to talk more about that term, and we're inviting you to listen closely, listen intentionally, and add what we're saying to that point.
Is that mass is not weight.
It is not, and it's a very common misconception. You're going to hear adults make that mistake, but it's not. Weight is actually the measurement of a force, and we got some big words here. That'll all make sense in other units. And when we talk about these units, and this is why it's important, you cannot add or subtract different units. Even if they're the same thing, like a meter and a kilometer, those aren't going to be able, you can't add those together, and you can't add a meter and a kilogram. You can't add length to mass, and that's why it's important to hang on to these.
And then the final fact is that you can't add a square of something to something that is the square of 1, or it has no square.
Exactly.
And you wouldn't do that in math. You wouldn't add x plus x squared, and we can't add length times area, meters times meters squared. They just can't go together because they have different units. Unless they look exactly the same, they cannot be added together.
Now, what we do want to do is just kind of organize something. So what we have for you is a table.
So we have a table here that kind of organizes our thoughts into these different terms, variables, and units.
And we'll try anytime we introduce something to actually break it down in this way, that you can see that when we talk about time, we might actually represent time as a lowercase t. And forgive me for having kind of that little leg on the t. Sorry, habit.
Well, and that's going to help. The reason it's there is that as we start to add different variables and distinguishes it, from an addition symbol. It distinguishes it up from other different variables that we're going to be introducing to every different multiplication, different functions that you can use. So really, it's not an accident. It's there intentionally.
So we actually encourage you to get a whole different sheet of paper, and you can start a 3-columned sheet that says term, variable, unit, and just as we build and we introduce new stuff, you can kind of create a list, and that will actually become really helpful as you get further along this course.